Okay. Ek gaan weer so in Afrikaans en in Engels verduidelik. Ek wil hê julle moet asseblief julle memos by julle hou. Want ek gaan nie noodwendig so al die somme doen nie, maar ek gaan wel op die sketse vir julle goeie verduidelik. By die triek sal ek goeders die somme doen en ook verduidelik. So die eerste ene, hierdie een was actually ene wat ons al in die klas gedoen het. Hulle soek die vergelyking van MR. Dit is daardie lyn. En die catch by hom wat jy moes raak gesien het, is dat jy punt O het, wat die oorsprong is. So sy koördinaat is 0 en 0. This coordinate is 0 and 0, and you have the coordinate of M. And therefore you can work out the gradient with the gradient formula, as you can see in the memo. Once you have the gradient, you substitute it in, en dan kan jy nou weer 'n koördinaat gaan invervang. But if you look there, you will notice that this straight line cuts at the origin. So therefore your y value is 0. That's why the equation of the straight line is y equal to 3/2x. Okay, the next one you have to find is the equation of PR. Now, if you take a look there at the information given, you will see that they gave you the information of the equation of the line MS. So I'm just going to write it in the correct order. It's y equal to 5x minus 14. Which now means that you've got the gradient of this line, and you can steal it for the gradient of PR, because PR is parallel to MS, as you can see on the memo. So jy steel hom, maar die lyne is parallel. Maar jy moes eers die vergelyking in standaard vorm gekry het, en dan die formule of die metode wat hulle hierso gebruik is net 'n ander metode. As jy nou die gewone metode gebruik wat ons gebruik, the normal method is we would just say y equal to 5x plus c, and then you would substitute the coordinate of p. So jy gaan p daar insit, is 4 gelyk aan 5 maal met minus 2 plus c, daar gee vir jou minus 10. Minus 10 gaan oor, so die antwoord gaan wees 14. Okay. Right. Die grootte van theta afgerond tot 2 desimale. The size of theta rounded off to 2 decimals. Also, as I say, we've done this one. So we cannot find the gradient of PR we cannot find the gradient here to calculate this one. There are different ways that you can do it, but the easiest way I think it would be is taking the gradient of MR, which you calculated in the first question. So this gradient here is 3/2, and taking the gradient of PR, which we calculated, and it will be equal to 5. And then you all know calculating an inclination angle will be tan, and then the angle you want equal to the gradient. So therefore, finding the value of alpha, I would say tan alpha equal to 5. Then on your calculator, you press shift tan 5, and then you find alpha to be equal to 78,69 degrees. Vir beta gaan jy dan nou dieselfde doen, maar met die gradient 3/2, en dan kry jy hom 56,31. Al wat jy dan hoef te doen, is om te sien dat daai hoek en daai hoek is regoorstaande hoeke. Those two angles are vertically opposite angles, so you can just give it in your reason, vertically opposite angle, and then you will notice that theta and beta together are the opposite interior angles of the exterior angle, which is alpha, and that's why we do the subtraction sum there to find theta to be 22,38 degrees. Okay, dan moet jy bewys dat die koördinate van R as dit kan gegee word. Jy het die vergelyking van MR, jy het dit by 1.1 uitgewerk, hy is y gelyk aan 3/2x. So you've got that equation. You've also got the equation of PR. That's what we calculated at 1.2. which will be y equal to 5x plus 14. Now once you have those two, you will see that R is a point of intersection, therefore we let the two equations be equal to each other, en dan los ons net op vir x, en ons kry die antwoord minus 4, vervang hom in die vergelyking, en dan kry jy y se antwoord minus 6, en dit kan jy dan nou net daar gaan invervang vir die koördinaat van R. Ok, bereken die lengte van MR, ek gaan nie daar in dit kom nie, dis maar net die afstandsformule met jou twee koördinate, en dan sê hulle by 1.6 is die oppervlakte van PMR gelyk is aan die helfte van PRMR sin theta, bereken die oppervlakte van 3 op PMR, en hierdie is dan 'n som wat ons die trig nodig het van die derde kwartaal, so jy hoef hom glad nie te kan doen nie. Dan vra hulle gee die koördinate van S as PMSR 'n parallelogram. So dis daai enetjie wat ons so kan cheat. Ons weet nou R is minus 4 en minus 6. So ons kan sien dat hierdie minus 2 het minus 4 geraak, so hy het 2 minder geraak, daarom gaan daai 4 2 minder raak om 2 te word. Daai 4 positief 4 van die y-waarde het geraak minus 6, so hy het 10 dan minder geraak, so daarom gaan hierdie 6 10 minder minus 4 wees. So dit is net die verneek enetjie, daar is nou nie veel aan hom nie. So jy tel hom net af en jy tel hom net af. Jy kan dit ook met daai 2 gedoen het en dan met daai 2 gedoen het. So minus 2 word 4, daarom gaan minus 4 2 word en 4 word 6, daarom word minus 6 minus 4. Reg, die trig gaan ek gou vir julle wys, ekskuus. As ons begin by 2.1, hoop ek dat julle baie mooi kan sien dat hulle by 2.1 verwys na met behulp van 'n diagram en sonder die gebruik van 'n sakrekenaar. Hulle sê vir jou dat cos theta is gelyk aan negatief 7 op 5. Theta is 'n element van 180 grade tot by 360 grade. Okay, the reason, or the first thing we need to look at is the negative that we see there. That negative tells us in which quadrant we will work. So cos is negative in the third and in the second quadrant. But then we've got the restriction there which says it has to be from 180 to 360, and therefore we know the triangle will be in the third quadrant. Okay. Cos is adjacent of a hypotenuse. Hy's aangrensend teenoor die skynsy. Daar is dan jou theta wat jy gebruik, aangrensend gaan wees 7 en jou skynsy is dan nou 25. Please always check, you have a negative there. Wat se een kry die negatief? Onthou die radius is altyd positief, so jou 7 gaan die negatief kry. Nou gaan ons net Pythagoras doen om die onbekende sy in daai driehoek te bereken deur te sê 25 kwadraat minus 7 kwadraat se vierkantswortel. Hierdie is dan eintlik mos minus 7 kwadraat. Nou gaan vir jou die antwoord gee van daardie sy en dan kry jy 'n antwoord van plus minus 24. You get an answer of positive or negative 24. Please remember that you get two answers. En nou gaan jy kyk na die posisie van die onbekende woorde. Sou dit 'n negatiewe y-waarde wees of 'n positiewe y-waarde? And because it's in the negative direction, I therefore know that this is negative 24. Now they want you to calculate 14 tan theta. So I'm going to say 14 over 1 times the tan of theta will be opposite over adjacent, teenoor staan op aangrensend. Dis minus 24 op minus 7. And now you can just type it on your calculator, or you can work it out as well with your fraction rules. That will be fine, but it gives you an answer of 48. You don't have to show any calculations there. Okay, dan vir die volgende vraag gaan ek terug na die memo toe gaan, 2.2. I think we also went through this when we were in class for the last time, so I'm not going to get into that a lot. Die cos van 90 grade plus, remember this puts me, you first look at the quadrant to decide the sign. So this is in the second quadrant where cos is negative, and then you change the cos to sin. So onthou eers die kwadrant, so vir die teken, en dan kan jy eers na 'n kofunksie toe verander. 180 plus is in die derde kwadrant waar sin negatief is, soos negatief sin x. The tan of 225 will be the tan of 180 degrees plus 45 degrees, which will be positive tan of 45. En dan negatief die kos kwadraat van negatief x. Ons almal weet die kos van 'n negatief is in elk geval die positiewe kos. Maar daai kwadraat kan net die teken van die kwadrant beïnvloed. The square can only influence the sign you get from the quadrant, which is in any case positive. It cannot make that minus a positive. It can make a negative a positive, but not the minus. So daarom sal dit dan bly negatief cos kwadraat x. As ek die teller maal, is dit sin kwadraat x op 1 minus cos kwadraat x, en daarom is dit sin kwadraat x op sin kwadraat x, and that gives me a final answer of 1 for 6 marks. Julle kan kyk daar hoe lekker baie punte tel. Reg. Die algemene oplossing gaan ek hierso vir jou doen. Reg, so die eerste ding wat ons daarso gaan doen is net om met hierdie 2 te deel regdeur om ons funksie alleen te kry. En dit gee vir ons cos 2 theta gelyk aan negatief 0,22. Dan gaan jy druk shift cos van 0,22, onthou ons gebruik hom altyd as 'n positief, en dan kry jy 'n antwoord van jou verwysingshoek, jou reference angle. Only use the 0,22, né? Then you get a reference angle of 77,2909, don't round it off. Going to the cos diagram, in die cos diagram, so jy sien dat cos is negatief in die tweede en in die derde kwadrant, so die antwoord in die tweede kwadrant sal dan wees 2 theta gelyk aan 180 grade minus 77,29, doetjie. And the one in the third quadrant will be 2 theta equal to 180 degrees plus 77,29 degrees. And then remember the new thing that we spoke about, just writing the general solution, is to say plus k times 360 degrees. Plus k times 360 degrees. Right, and now this might be something that we haven't seen in class. Ons het dalk nog nie hierdie enetjie gesien, so 'n voorbeeld nie, waar die 2 nog voor die theta is, want jy sien hy was deel van die hoek. It was part of the angle, so we couldn't divide it at the beginning. The 2 that we divided at the beginning was that 2. So when the angle has got a value in front of it, a coefficient, then in your final step, at this stage, we are going to divide with 2, divide that answer with 2, divide that answer with 2. Divide with 2, divide with 2, and divide with 2. So net soos wat jy gewone los op 'n x sommetjie sou gedoen het, maar daar 2 voor die x was, dan gaan jy mos in die laaste stap deel met daai 2. So die antwoord wat jy nou kry uit kwadrant 2, the answer you get from quadrant 2, will be that answer, 180 minus 77,29 divided by 2. And that gives me an answer of 51,35 degrees plus k times, and what happens when you say 360 divided by 2, it will be 180 degrees. So even though this was a cos graph, in this case, because of the 2 in front of the theta, it now becomes plus 180 degrees. And you must just remember to write k, an element of z. Okay, om net so 'n sekond oor hierdie vraag praat. As jy nou terugdink aan ons trig-funksies, if you think about the trig functions, we said that value in front of the angle influences the period of the graph. En hierso kan jy sien algebraies doen dit dan ook om te deel met 2, beïnvloed dit die periode van die grafiek. So hy doen dit presies algebraies, presies soos wat jy dit geleer het, grafies wat ons dit gedoen het. Okay. The next one is the identity. 2.4. tan theta minus sin theta oor 1 minus cos theta. Ok, ek dink ons almal weet, en dink aan die eerste stap, om tan te verander na sin theta op cos theta minus sin theta gedeel deur 1 minus cos theta. Then looking at the top, I know that I should get a common denominator. And what I do at the bottom, I do at the top. So it's going to be cos theta as my common denominator. This one I didn't do anything to it, so it just stays sin theta. This one I had to multiply with cos, so it is sin theta, cos theta. Right, die noemer gaan ek nie nou ietsie aan doen nie, ek los hom net so 1 minus cos theta. En dan sal jy sien dat daar nou een ding is wat jy kan doen by die teller. There's one thing that you can do at the numerator, and that's to take out the sin in common. But I think the thing that's bothering us here the most is that we have a fraction inside of a fraction. En ek hoop dit irriteer julle ook, want ons wil graag van dit ontslaa raak. So ek sou hierdie ding gaan oorskryf as sin theta minus sin theta cos theta gedeel deur cos theta. En dan aan die onderkant sou jy mos nou hê gedeel deur 1 minus cos theta. So you've got divide by 1 minus cos theta. But you must remember, if you were to make this a fraction, it will be over 1. So if you want to write it in one sentence, we would change the division, that one, we change it to a multiplication, and then the second fraction needs to swap around. So it is 1 over cos theta over 1, but it has to swap. Then it's 1 over 1 minus cos theta. Okay, now I'm going to take out the sin in common. And it's 1 minus cos theta, and now I can see that it's looking like something that I want in the next one to cancel out in this part. Mal met 1 min cos theta, so jy kan sien hulle kan uitkanselleer. So nou kan ek net daardie enetjie uitkanselleer met daardie enetjie. En waarmee ek dan nou oorbly hier is sin theta op cos theta, and that gives me, moenie langs aangaan nie, ek gaan nou net hier aan want ek het nie plek nie, dit geef my tan theta, en dan is die linkerkant gelyk aan die regterkant. Left side equal to the right hand side. Die volgende enetjie, kan julle dalk 'n bietjie skrik maak, might scare you. They say 2.5, if A alpha plus beta is equal to 90 degrees. Okay, baie belangrik wat hulle hierso vir ons sê as hulle sê alpha plus beta is 90 grade. Dit beteken hulle is komplementêre hoeke. Nou komplementêre hoeke is vir ons baie belangrik wanneer ons in trig werk, né? Want dan kan jy ook met jou kofunksies werk. We can work with our cofunctions. So what they want you to calculate is cos 700 degrees over the sin of 70 degrees minus sin alpha over sin 90 degrees minus beta. Okay, as ek net hierdie boonste deeltjie vir jou op so 'n klein manier anders te kan skryf, is dat hy nou kan wees, jy kan alpha ook kry of jy kan beta kry, net soos wat jy wil. Jy sal sien daar jy alpha en daar jy beta. As jy alpha in terme van beta gaan kry, we want to get alpha in terms of beta, then it will look like this. Alpha is equal to 90 degrees minus beta. Dit maak dit dan nou vir ons baie maklik om daai alfa van ontslae te raak. Die cos van 70 gaan ek nou 360 aftrek en dan weer 'n keer 360 aftrek en dit gee vir my cos as jy gaan vat, laat ek nou die sakdoek maar iets kry, om dat te wys. Take 700 degrees minus 360 gives you 340 degrees. So 340 I can write as 360 minus 20 degrees over sin 70 degrees. Now I'll substitute alpha with 90 degrees minus beta over sin 90 degrees minus beta. This one can now just be the cos of 20 degrees, and then I can change the sin of 70 degrees. I can also convert that to a cofunction and say that it is sin 90 minus 20 degrees to get them to look the same. And this one I can just make 1. Right, so here I've got cos 20 degrees. The sin will change into cos. Hy word nou ook cos. En dan het ek 1 minus 1 en my antwoord is 0. Okay, ons is uitgenoem. Dit is dan jou moeiliker triegvraag wat ons daar so het. Dan kom ons by die triegfunksies, vraag 3. Die 2 wat hulle vir jou gegee het is 2 cos x plus 1 en die ander een is 1 minus sin x. Okay, ietsie wat ek graag wil julle dadelik moet raak sien, something that I want you to take note of, is that g is not in standard form. It doesn't look like we want it to look. So I will shuffle that g of x equal to a negative sin function plus 1. Okay, the first question is for you to draw both of these graphs. So you can see that this period hasn't changed and this period hasn't changed. So therefore you know this graph's period is 360 degrees. So to find the critical points, remember I always divide it by 4, and therefore I'm going to substitute into every 90 degrees. And this one, it also doesn't have a value that influences the period. So the period is 360 divided by 4. And that also gives me that the critical points will be at 90 degrees. So all you literally have to do is you can type that into your calculator. I'm just going to show you one example. Ek wil een voorbeeldjie wys. Sê maar met die cos grafiek, jy sal sê 2 cos 90 grade sluit die hakie plus 1 en dan gee hy vir jou 'n antwoord van 1. So by 90 grade gaan jy net 'n kolletjie 1 stip en jy doen dit met al jou waardes en dit gaan jy doen vir, jy moet hom skets vir van min 90 tot by 360. So jy gaan begin met min 90 daarin vervang, dan 0, dan 90, 180, 270 en 360. So those are the values that you would substitute into them both, and then you just calculate it. Geef jy die punte, koördinate wat jy gaan stip, en dan is dit dan nou hoe jy jou punte het om hom te kan verbind. Die volgende vraag is om die amplitude van f te gee. So daar is jou f grafiek. Jy weet waar die amplitude is om af te lees. So die amplitude daarso is dan nou net 'n 2. Volgende enetjie, laaste enetjie. Ek dink dit sal dalk enetjie wees wat julle op laat krap. Hulle vra jou bepaal die waardes van x waarvoor f minus x gelyk is aan 0. Okay, they're asking you to calculate f of x minus g of x equal to 0. Remember, this is one where you can just manipulate it to be more understandable. And there was a question like this in paper 1, and surprisingly, so many of you, well, not that many, but you were asking me, you don't know what this means, and we've spoken about this a lot in class. Dit beteken, hulle wil weet waar is die twee grafieke gelyk aan mekaar, so jy moet letterlik net die een grafiek gelykstel aan die ander grafiek. You have to let the two equations be equal to each other. So we are going to say 2 cos x plus 1 equal to 1 minus sin x. Daai plus 1 en daai plus 1 kan mekaar uitkanselleer. En dan gaan jy nou net hê, ek sal daai enetjie hier los, soos 2 cos x gelyk aan negatief sin x. Okay, now when I look at this, do you see it's not that one where you need to get the functions the same so you can throw it away, want jou hoeke is dieselfde, hulle albei is x, so dis geen probleem. As ek net hierdie kant deel met cos en ek deel daai kant met cos, dan gaan my sin tan word en ek het in 'n tan nog steeds die sin funksie en die cos funksie. Maar omdat ek gaan deel met cos hierso en gaan deel met cos hierso, gaan hy nou so lyk, daar word 2 gelyk aan negatief tan x. Okay, you can't work with it when it's negative, so I just swap it around, tan x equal to negative 2, and then we're going to say shift tan of 2, it gives us the reference angle, which is 63,4349 degrees. This is negative, so in our cast diagram it will be in the second and in the fourth quadrant. So x is going to be in the second quadrant, equal to 180 degrees minus 63,43 plus k times 180, which is not really necessary, but you can just put it there. And that gives me an answer of 116,57 degrees plus k times 180. Now, if you look at this graph, you will see that these two graphs cut in the negative side, and then there as well, and then there as well, which is, when you look at this, 180 degrees further. So you don't even need the other equation, the one in the fourth quadrant, but you are welcome to do that, to say 360 minus 63, that will also give you the answer, maar jy kan net 180 ook by hom tel. So jy weet, hierdie is een van die antwoorde as jy na jou skets kyk, die ander een is 116,57 plus 180, that will be 296,57 degrees, en dan kan jy ook 180 grade gaan aftrek om die ander enetjie te kry, wat jy gesien het is op die negatieve kant, and that will give you 63,43 degrees. And there you've got all three of the values that you have on your sketch there calculated as well. Reg, vraag 4, die meetkunde. Die eerste een is 'n bewys. Ek gaan nie die hele bewys vir jou doen nie, jy het alles daarso. Ek gaan net vir jou wys, sy begin is Pythagoras. Jy doen die konstruksie, jy sê jy verbind OP, you're going to do the construction and say that you've joined OP and OR, and now you've got two triangles. You're going to use congruency to prove it, to be able to do Pythagoras when we use theorem 1. So here I've got a 90-degree angle, I've got a common side, and those two are radii, so they are equal to each other. So I've got a 90-degree side to prove congruency, and therefore I know that the two triangles are congruent, and that must mean that OQ and QR will be equal to each other. In the next one, question 4.2, we have the diagram where they say that BD is a diameter, dis 'n middellyn. Wat beteken dit vir ons? Dit beteken dat daai is 90 grade. Dan sê hulle ook vir jou O is 'n middelpunt, O is a center, so that means there's a line onto a chord and the chord BC is being bisected. That also tells us that these two angles will be 90 degrees. Then they tell you that O1 is 40 degrees, and they've told you that CD is 40 millimeters, and AB, this short one, is 15, and that makes that one 15 as well. So the first question that they want you to calculate, and as I said, please keep your memo with you. Hou asseblief jou memo langs jou, want ek gaan nie alles met die redes neerskryf nie. Kyk asseblief vir my mooi daarso. Die eerste enetjie wat ek gaan moet bewys is dat daai hoek 90 grade is met die lyn van die middelpunt loodreg op die chord BC. The line from the center is perpendicular to the chord. It was given that those two sides are equal. Therefore, A1 will be 90 degrees. You've got A1 as 40 degrees and you can calculate B as 50 degrees because of the interior angles of a triangle. The next one was angle D that you had to calculate. At angle D, it's that one. Now you're going to have to use the proof to say that angle C is 90 degrees, angles in a semicircle, and then you can find D to be 40 degrees. Next up, you had to find the length of line AE. Jy moet daai een se lengte kry. So jy soek basies die lengte van 'n radius of 'n gedeelte van 'n radius. Nou jy moet vir my asseblief baie mooi kyk by hierdie enetjie om hom dan nou reg uit te werk. Ons weet dat daai hele lyn is dan nou 30. Jy kan sommer hierso kyk op die memo. So they used Pythagoras with that side as 40, this side as 30, and then you can calculate the length of BD, which is a diameter. In other words, it's 2 radii. So when I calculate that, normal Pythagoras, 40 degrees, 40 squared plus 30 squared, square root gives me 50. Dis die deursnee, dis die lengte van BD, that's the diameter. So they divide it by 2 to get the length of the radii, that is 25. And then they say OA is equal to half of CD. It's the midpoint theorem. In other words, OA will therefore be 20. Hierdie theorie wat hulle hierso gebruik is ene wat julle in graad 10 gedoen het met meetkunde. This is a theorem that you used in grade 10 and it does not occur a lot. It means when this side and this side is equal to each other and that side is equal to each other, then you can assume that these lines are parallel and that it is being bisected. Okay. Daai lyn is die helfte van daai lyn. This one is bisected from that one. Ek wil so ver gaan om te sê dat jy nie hoef te worry om so ietsie te kry nie. You wouldn't really get this grade 10 theorem, so don't worry about it, but just take note of it, and I'm sure you will remember that was the only theorem that you did in grade 10. So that's if this one is equal to this one and this one is equal to this one, then these sides are parallel and daai een is die helfte van daai eentjie. So that means that length is 20 millimeters, and for that reason AE will be 5 units or 5 millimeters. Okay, we are almost done. The next one we have here is number 5. I'm going to use colors before I read the question. So they say that J1 is X. I'm just going to make it yellow, and that J3 is Y. I'm going to make it pink. And now I'm going to look for angles that might be equal to it. So I see an isosceles triangle there, angles opposite equal sides. Here at the Y value as well, angles opposite equal sides. There's no center in this one and there's no tangent, so I assume we are looking at the cyclic quads. And when I look at it, you can turn the page if you're struggling to see it, jy kan hom draai, dan sal jy sien dat JN onderspan vir M, JN subtends the angle M, and it also subtends the angle K1, wat dan nou beteken dat hierdie hoek ook Y sal wees vir angles in the same circle segment, hoeke in dieselfde sirkelsegment, en dan sien ek ook dat hierdie ene JK onderspan vir L, JK subtends L, and it also subtends N1. That's about the angles that I can find in terms of X and Y at this stage with the cyclic quad. So the first question is to find two other angles that are equal to X. And there I did it, I said that L is equal to X because it's angles opposite equal sides. And then I said that N1 will also be X because it's angles subtended by JK. So angles in the same circle segment. Next up, they wanted you to prove that O2 is equal to P2. In other words, let me just get a pencil here. It's this angle that they want you to prove equal to this angle. Now, just looking at those two angles, I hope that you can also see that they aren't connected to each other. Hulle word nie verbind aan mekaar op enige manier nie. Daar's geen netkundige rede om hulle aan mekaar te verbind nie. Maar met die kleure wat ek daarso het, kan ek sien en ek hoop julle sien hom ook dat hierdie ene, this Q2 is an exterior angle to a triangle that I have something of. And also P2 is an exterior angle to a triangle where I have the two opposite angles of. So in other words, remember we said that this one is X and the pink is Y. Let's put all of them in there. Sit net hulle almal se X en Y neer. So as daai die buitehoek is van hierdie driehoek, dan gaan hy gelyk wees aan X plus Y. En hierdie is die buitehoek van hierdie driehoek, dan gaan hy gelyk wees aan X plus Y. Now for those of you that might be struggling to see it, I'm just going to draw it in for you as daar nog iemand is wat sukkel. Daarso is die driehoek. En daarso is die buitehoek. Daarso is die driehoek en daarso is die buitehoek. So I can prove that Q2 is X plus Y, exterior angle of a triangle, and P2 is equal to X plus Y, exterior angle of a triangle, and therefore they are equal to each other. The next one we have to prove is that JQ is equal to JP. That means they want you to prove that this side is equal to this side. Now the way that we can prove sides equal to each other is to prove that the angles are equal to each other. So we want to work with the angles. Ons wil daai hoeke gelyk bewys aan mekaar en dan kan ons sê daai sye is gelyk aan mekaar want is sye teenoor gelyke hoeke. We will say sides opposite equal angles. Now looking at P4, this angle, and Q4, do you see that in there we've got a vertically opposite angle? Ons het regoorstaande hoeke daar. So dit sou beteken dat P4 gelyk is aan X plus Y, regoorstaande hoeke, en Q4 is equal to Q2 because of vertically opposite angles. So I've proven those angles equal to each other, and now I can come to the conclusion that JP is equal to JQ because it's sides opposite equal angles. Okay, dit was hy. Dan kom ons by die heel laaste enetjie. Twee sirkels met verskillende radii word geteken en hulle sny mekaar en hulle sê P is die middelpunt. So we've got a center here. And line CP is extended to A. Sien julle, hulle sê nêrens iets van 'n raaklyn nie. Daar is nie raaklyne nie, jy mag nie 'n raaklyn gebruik nie. Goed so. As ek net na die groot sirkel kyk, if I just look at the bigger circle, I hope that you all see we don't have a center, we don't have a tangent, but in there I do have a cyclic quad. En ek wil hom net gou daarso vir jou wys, dis C, K, P, T. It's making a cyclic quad in the big circle. You all see it, en dis dan nou ook die crisscross enetjie. In the smaller circle, I just see that I've got radii, there's radii, so I know that this angle will be equal to this angle. I know that this angle will be equal to this angle. And I also see that I've got an angle at the center, angle at the circumference, and also another angle at the center, angle at the circumference. Let's see if there's another one. No, I don't really see another one there. No. Okay, so that is what I see there. The first thing that they want you to prove is that K2 is equal to C. And just by making the observations that I just did, net met die goedjies wat ons nou gesien het, kan ons sien dat K2 gelyk gaan wees aan C. K2 is gelyk aan T2. K2 is equal to T1 because its angles opposite equal sides because of the radii. So hulle twee is gelyk aan mekaar oor die radiusse. En dan het ons ook gesien dat hoek C gelyk is aan T1. C is equal to T1 because its angles in the same circle segment. And they have proven that K2 will now be equal to C. You can just check the memo there. It will say it in the same way. The next one we have to prove is that K1 is equal to 2 times T2. So K1, it's this angle, must be equal to 2 times this angle. Now when I look at this one, I can also see, I'm going to make 2 circles here, so you see this is now a different angle. Do you see in the sketch that this is also angles in the same circle segment with P2? Okay, if you're struggling to see it, you can just turn your page, you kan hom net omdraai, want TC onderspan vir P2 en TC onderspan ook vir K1. Daar is ons daai twee hoeke. Nou wanneer ek na hierdie skets kyk, and I hope you see it as well, is that it's very easy to see there that P2 is the exterior angle of triangle PAT. Therefore, if I name this angle Y, so I say let A be Y, I can say that T2 is also equal to Y because its angles opposite equal sides because of the radii, and therefore P2 will be equal to 2 times Y. It's the exterior angle of the triangle. Another thing that you can use is angle at the center equal to 2 times angle at the circumference to find it to be 2 times Y. And then I know that K1 is also equal to P2. Number 6.3, the last one, they want you to prove that P4, which will now be this one, is equal to 2 times C. So it's 2 times that one that has a dot, 2 dots, plus K1, which is this one that is 2Y. Okay, so looking at that, I can see that this is the angle at the center, and I have the angle at the circumference there. So the angle at the circumference is dot plus Y, and therefore this one will be twice the size of that one. 2 times dot plus 2 times Y, and that's exactly what they had there. So that's just because of angle at the center, angle at the circumference, and that is that. Please work out some more geometry. Asseblief werk nog Euclideese meetkunde uit. Hierdie enetjie het nie baie tricks en traits in hom gehad nie. Julle gaan nodig hê om nog van dit te oefen, en sterkte en hardleer, en ek weet julle is al baie goed in. Wees rustig, julle het dit.